YouTube, all of those.
Can I share it on my LinkedIn as we're talking?
Yeah, absolutely.
Is that a good?
You should.
A good play.
While you're looking for that,
how do I find it?
Go to Composites Weekly. The Composites Weekly page. We should be live streaming on that as we speak.
Composites Weekly. Yes.
All right.
And you've had Steve Barber. Good guy.
Yeah. He actually came on right before you.
Really?
Yeah.
Nice.
Steve interrupted my lunch. I'm just kidding. No, I'm just kidding. Okay, so let's get started. We're live. All right, welcome back. JEC World, Day 1, 2026 here. Joining me is Tom Bloomfield, co-founder of Fyous. What's interesting, I've had his co-founder, his partner, Josh Shires. He's been on the podcast before, probably a year or so ago, introducing this incredible technology that we're going to be talking about today. So what they've invented is a polymorphic molding, a reconfigurable molding system made from thousands of digitally controlled pins. These form shapes in minutes, ready for composites layup. These can be used in compression molding, work molding, thermal molding, you name it. And what's interesting is what I've learned about this technology is it's been around for a long time, but you've taken this patented technology and you've run with it. So you've been a startup booster finalist.
Yes.
And so you're located over at, give us a location.
In Hall 6, right at the entrance as you come in. You'll see the big startup village there.
Yep, Startup Village. Go visit them. This is amazing technology. We're about to showcase. I want Tom to introduce himself and talk a little bit before, but we're about to, showcase a video on here that shows what he was giving me a little demonstration here with the dental work. So you can tell me a little bit more about this. First of all, tell us about yourself, Tom, and your background. I know who Josh is, but give us your background real quick.
Yeah, of course. So my name's Thomas Bloomfield, one of the co-founders of Fyous.
Yep.
My background is an engineer by trade, so similar to Josh, both engineers. Yeah. Except Josh just enjoys the technicals of the business way more than I do. Yeah. I like to look at the top level and stay there. Right. He loves getting a lot of the details. Yeah. So we've always kind of split in that technical operational way.
Absolutely. And
I've typically looked after a lot more commercials, but it's a good world to be in where you've kind of got the real knowledge and understanding of the technical requirements of what the customer needs, but at the same time be able to really jump into the commercials and go through there. So I've done a lot of time with people like Unipart, Rolls-Royce, big major companies, largely in their tooling requirements to manufacture, which then helps feed into why you really start to understand the need for flexible tooling approaches and things that you can just not have to invest loads of money each time you want to change something, but be able to change things really
automatically.
Quick.
So this is like you can change a mold in minutes.
Yes.
I mean, just automatically, and it's all digitally done, right?
Yeah. So if you imagine it, I always like to describe it as like those children's toys. Yeah. You've got like the pins in them, and you put your hand in or your face in, hopefully nothing else, and it creates that shape. Yeah. And then from that shape, you can do what you want. Yeah. But our methodology is instead of a few hundred pins, you've got thousands of pins, and they're each really, really small. I mean, in standard tools, you're talking like 0.8 millimeters in diameter, but in our dental application, you're like 0.3 or less. Like you're really, really small pins. Yeah. Right. And in each one of them, we can digitally control that, and then we can lock that in a location, and that creates like a form, like a shape. Yeah. And that then enables us to take that form and shape and use that. I mean, that's a platform technology that you can then use across so many different methodologies. Right. And that's exactly what we do.
I want to give a demonstration real quick. Is it going to show this process on the video?
Oh, nice. Cool. Yeah. So, I mean, if you go into this, you'll see once Josh removes his pretty face out of it, you see some of the technology. And essentially, you've got the super tiny pin. And imagine one of them. Yeah. And then in this, you've got loads of those super tiny pins. We digitally control each one, move them to location. And in this, though, we're split into 5 tools. So these 5 tools can now fold up into one place. And that then forms the female mold, if you like, of the aligner. You bring over the membrane, you thermoform directly down into that. And then what that enables you to do is essentially get an aligner off of that, which you trim and you stick it on someone's teeth. And now that process didn't waste anything. It literally just produced an aligner with nothing thrown away.
Absolutely.
The current way of doing that, just for, I know we had a little chat before, but for everyone else's benefit, the current way of doing that, let me fiddle away. You attached it back on.
Oh, whoops. Sorry about that. No, but while you're trying to, there you go. This is amazing, though.
So yeah, I mean, typically, any person who wants their teeth aligned, they go get these printed. So I'll zoom in for everyone else over there. They have these tiny little models printed. And these models are basically, it's a scan of their teeth, and then each one is like a tweak of their teeth, moving it a tiny bit at a time. Now, a typical patient might see about 50 of these models printed for them. And then they go and thermoform over each one, and that gives them the actual aligner. Now, in that, as soon as they're done with that, that's just thrown away. It's put in the bin. That's a huge amount of waste, right? And but that is pretty explicit of what all tooling is like. You use once you've used your tooling, you throw it away. So our concept is all about bringing it to the point where actually you're not throwing it away every time. You're reusing it every time. You just move it into the next shape and the next shape, and you do that really quickly. Opening up this world where you can mass customize product because you've not had to kind of like commit to a high tooling spend to make the product.
So you can change. You've got some other things over here that you want to showcase.
So
nice.
You've got here, this is my mini version for travel. I'm going skiing after this week, so I need to be able to go there with this, and I didn't want to carry a giant tool with me. But
that's amazing.
You get a little tool like this, and what this can do is
can I feel that?
Yeah, of course. Have a feel. So that's currently in its like locked out format, which you load that into the machine. The machine moves all those pins into position, and then once it's done with that, then you go and use it. So use it in whatever form. In this case, it's wavy form. You might thermoform over that. You might lay up a composite into that, whatever you want. And once you've created your part, you then take your part off. You put that back in the machine, changes the shape again, and off you go. But what we're really working hard on is how to automate that whole process for industries. So what we've done in the footwear industry is we've gone, well, we can make a last out of this, and we can bring 3 of those tools together, a bladder in, inject into that, and then create a solid part, right? And then once you've got a solid part, we change the shape again, and we do another part. Whereas in the composite industry, you might want more of a kind of a wavy shape or something like that. Again, membrane over it, lay up the composite onto it, like maybe like this part here, lay that up onto it, and that's been made on one of our tools. And then you've got yourself a physical part.
A carbon fiber shoe sole.
Exactly. But you know, like the fancy like Nike and Adidas trainers that have like the carbon plates in them to make you run faster. Well, essentially, like imagine now you might be able to tailor that to each person.
So somebody who say they're making a part such a size as this, you could get a mini mold, so to speak, Fyous, smaller scale type. I mean, what are the ranges of these?
It's kind of the beauty of it is there's nothing that really forces you down like specific sizes. You could be doing something like as small as dental, it's tiny parts with super high detail, right the way up to, I mean, we've spoken to big aerospace companies before about what about doing like a whole wing or like these kind of massive scale parts where actually we've got maybe, we might use 2 or 3 millimeter pins, but we might use, millions of them, and you move all of them, create a part, and then you can keep going. But in that kind of industry, you go ask someone, I don't know, Airbus or Spirit Aerosystems or someone like that, how much they really spend on tooling. And like they'll be talking millions per program.
Absolutely.
And if you imagine something like this, that kind of size system might cost you a couple of million. But if that can keep being used for every program after that, that's suddenly like, oh, well,
one
now it doesn't cost us
to rule them all, right?
Well, yeah, exactly.
No, I love it. It's yeah. I mean, if you're talking cost savings, tooling is a very expensive undertaking. But I'm noticing in this, you've got, I don't know, thousands of pins probably right here, and they're aligned, they're configured, and they're spacing. Are there pins in between the pins here?
So they're not. So there is gaps in between.
Okay.
And the way we deal with them is you typically will put like a membrane over that.
I see. Okay.
So you and like in the it'd be a good video to show actually if you want to jump on our YouTube quick.
Yeah.
We could pull it up. Or actually even from the website, you jump back. Yeah. And you go into the orthotic space.
Right, let's see. I may have to.
It's not playing ball there, is it? Just press back or something. I don't know.
There we go.
There you go. Fyous.com. Jump into industries.
Okay.
And then from there, you go to orthotics.
Orthotics.
Oh, actually, it might be under footwear. Let's just
watch
see what watch video does. Yeah.
This one.
Hit me with that video. Let's see
that.
Let's play guessing.
All right.
This is promising.
Okay. Let's do it.
So yeah, essentially, now we've got in this video similar to the dental one. You've got like 3 tools rather than the 5 tools in dental.
Okay.
But the way we seal the pins is we use a membrane. So you've got 3 tools there, all the pins moving into position, completely automated based on the model that you're putting into it.
Okay.
And then what happens is those 3 tools, they all start to fold up.
Okay.
Which is really cool. So you see them now folding into place. You bring down this bladder into the middle, and then we inject straight into that bladder. That expands out, and that locks in location. So the PU inside cures.
Okay.
And then you open it back up. You take the part out. You break off you peel the membrane away, and suddenly you've got yourself a physical PU part.
That is awesome.
Now, again, think about this to composites. You could be using parts like that to lay up on. You could have really quick tooling. I mean, we're talking like less than an hour to make those parts.
Yeah.
In theory, if you had the money to pay for the machine, you could have even lower cost than that. Even lower time than that.
Right.
You could have these changing parts that you want to lay up onto, and then you've got the tool then going forward forever.
Yeah.
So yeah,
that's incredible. Cool. Tom, this is amazing. And again, over at the Startup Village,
yes,
people can find you.
Yeah,
go check them out
in Hall 6.
Hall 6.
We're right at the entrance.
Yep.
Come and see us. There's loads of other cool, innovative businesses there too. So it's worth a visit just for those guys. Yeah.
And check them out at Fyous.com. That's the website.
Our very fancy new website.
Yeah, it's a really cool website.
Our marketing manager did an excellent job of getting that sorted out.
I think I mispronounced it at the beginning. It's Fyous, not Fyous.
Yes. Yes, it's Fyous. Like it fuses to you.
Yeah, Fyous. I see the play on words there. So.
Don't worry. Some other people call it Fyous and everything else. People are like, that's a pretty offensive name, isn't it? Like, I promise you, it's not what we're trying to say. But if you come up north in the UK,
it's a little
you'll literally get, someone says this is for you, they'll be like, Fyous. So, yeah.
It's amazing. Tom, always a pleasure. Thanks for stopping by.
No problem.
So far, the show's been really well for you, right?
Yeah. Oh, good. Brilliant. Yeah, lots of good conversations. I'm sure there'll be lots more to come.
Well, I wish you the best of success. Have a great show. And we hope to see you again soon.
I'm sure you will.
All right. Thanks.
Cheers, John. Take care. Bye-bye.